In this video, we're going to begin work on the two-column table. The two-column table is a very important, if not the most important, idea in our class. Before we start using a two-column table, let's just take a look at what one is like. So in mathematics, if we're going to build a table, it often looks like this. Columns run up and down. Rows run left and right. Now, when we build our two-column table, the first thing we're going to do is remind ourselves that the left column is for operations and the right column is for inverses. Then we're going to imagine that we substitute a value for the variable. And we're going to make a row for each operation that acts on the variable. In the left column, we're going to list the operations in order that you would use to simplify the expression if the variable was a value. In the right column, you're going to list the inverse operations row by row for the operations you found in the previous step. Once you've built your two-column table, then you start at the bottom of the right column and you work your way row by row to the top. You'll be using a reverse order of operations to isolate the variable. Last, you'll always check your solutions, and if you're not sure how you should check your solutions, the left column is always going to have the right order of operations to simplify the expression, because that's what you use to build the two-column table to begin with. I'm going to show you an example using linear equations, and then in the next video you'll get to start working on them yourself. Here's the equation I'm going to solve. Step one is I start to build my table. My first row is for operations and inverses. Instead of writing that out every time, I'm just kind of abbreviating it. Then I look at my left expression. I count the operators. I can see there's two of them. There's a multiplication and an addition. And that tells me I need two rows underneath my first row. I start at the left again. I pretend I'm substituting a value for x, and then I list the steps I would use to simplify. Because multiplication comes before addition, if x was a number, I would multiply by -3, and so that goes here. This is my little multiplication symbol I use right here. And the second one says I'm going to add 11. I now move to the right column, which is going to have my inverse operators. The inverse for adding 11 is subtracting 11. The inverse for multiplying by -3 is dividing by -3. Once my table's built, I can solve my equation. I go back to the original. I start at the bottom of the right column. That tells me the first thing I should do is subtract 11. So I do, and then I simplify. I then move up a row. This row tells me I need to divide by -3. So I divide both sides by -3. On the left, I get 1x, which is simply x. On the right, I'll get +2. And then, as always, I want to check my answer. So I return to the original. I substitute my answer for the variable in the original. I follow the order of operations. That is, I'm going to multiply first and add second. And I see that both of these expressions have become 5. And that helps convince me that my answer truly is the solution. Now, before I end this video, I want to warn you about something. The biggest problem I have with students learning the two-column table is some students that say to themselves, well, I already know how to do that. And it's not the case they really do. It's that they do it a different way. And so they fight against doing it this new way. And they'll stick with their old way for a little while, and then it becomes obvious that the old way wasn't very efficient, and only then do they start trying to learn this new way, and in the process they fall behind. So I've started with a very simple example here so I can show you the process to go through. As we move forward over the next couple of lessons, you'll realize how powerful this single idea can be. Well, that will conclude this first video where I've introduced the two-column table.